Hey, hey!
Welcome to another meetup of JavaScript Israel. Yeah, make it, you make it. Okay, so yeah, let's say some thank yous. First of all, thank you for Powtoon, our sponsor for today. They are sponsoring this video, so we can all enjoy later. So give them a round of applause. Thank you, Powtoon. Powtoon makes these videos, like intro videos that you can make yourself without a video editor and stuff like that. So if you have a startup and you need like an intro video for your startup, check them out. Great. So we also have this form, which if you're looking for a job, you can like submit this form, and we will connect you to the people in Powtoon. Directly to the one who, like the team leaders and stuff like that. The first lecturer for the day, Nick, give him a round of applause, and also Ben Stam. They invested a lot of time to prepare these lectures, and it's not an obvious thing, so yeah, it's always like a great pleasure to have these great speakers, and also Benjamin Greenbaum, who organized this event. So he picked the lectures and stuff like that. So give also a round of applause. For those of you who don't know us, our purpose in life is, first of all, people. Okay, this group is all about the people, and we want people to get connected together, because we can all watch these YouTubes later on, but like we believe that if we build a community should be about like actual connection with people. So it could be offline and online. And be kind. We created this group because we wanted a soft start into JavaScript without being judged, okay, that we don't know something or some API or something like that. So this is like the most important principle in our group. So you can see it on the Facebook group. We make sure that everyone stay inside the safe limits and not like bashing each other and stuff like that. And this is a very important principle. And also have fun with JavaScript. So this you can see in our like lectures like today and the other meetups. We're searching for more speakers, okay? Male, female, everyone, just apply. If you have a topic, even if it's a 5-minute topic and you just want to get your feet wet, just apply with the topic, and we'll make sure you're scheduled. Thank you, Mayor. Yeah, Mayor. Give her a round of applause. Okay. In the following minutes. Okay, and one last thing is that we need more sponsors for the next meetups, okay? So we have openings for sponsors, so we could sponsor the video and the production, all that stuff, and food for the meetups and stuff like that. So please, if you are working in a company, in a big company, would like to contribute to the community, because this is like a community group, it's non-profit, so make sure you point them to this link. It's very important. We need the money to sponsor all these things.
So, hello everyone. My talk is going to be in English. And I'm going to talk about, the title is Yield to Iterable Iterator Generators. Let's start. So a little bit about myself. I like building stuff, I like learning things, I like the web. I work at a nice startup called 90min, which is, I'm going to read this, although I was supposed to learn it by heart. We are building the largest media platform where thousands of writers produce sports and esports content that is consumed by over 70 million fans and gamers around the world. In many languages, cutting-edge technology, cool people, let's proceed. Oh yeah, and we plan to take over the world. So let's talk about iterables. The talk is divided to two parts, where I'm going to talk about iterables, and then about generators, and maybe about anything else if we have enough time. I will cover these topics, so without further ado, let's start. So first of all, what's wrong in this picture? So let's say I have an array and I want to iterate it. I simply want to print each and every one of its members. I can use a for each method. Nice. But if I have something which is array-like, let's say arguments or a node list or a string, then I have to do it in this awkward manner. But okay, you know, we're used to it. Then we have the new collections in ES 2015. So we have this new form of loop for of. All right. But then you get to the whats, where I simply want to print a single character in a string, and what I get instead is this. So this is less than ideal, and we have three different ways to do the same very, very basic task. All I want to do is see members of a collection. I also can't easily iterate anything that's not built in. That's custom, that I've made. And the iteration entails coupling and lack of encapsulation. You need to know what you're iterating in order to decide how to iterate that. And then you actually need to use the collection's implementation details to do that. So for example, I need to know the length property just to get the members. I don't care about the length. I care about the members. So we can do better, and iterables solve all that. Let's see this better example. We have an array, and we have a function which returns an array of different iterables. So we have a string, and an array, and arguments, and a set, and a map, and all of this can be iterated in the same way and without dealing with any of the implementation details. This is pretty awesome, if you ask me. Let's see how it works. So an iterable is an object which can be iterated. An iterable is something that has a Symbol.iterable property, its own or in the prototype chain, whose value is a function which returns an iterator. If anyone doesn't know what Symbol is, it's a new fancy way of making a unique value in ES 2015, and they can be used as object keys, which will also be unique. That's a bit abstract, but basically it's another key. So this is how it formally looks in TypeScript notation. It's an object which has a property of Symbol.iterator, which is a function which returns an iterator. And we have plenty of built-in iterables in ES 2015. We have strings, arrays, all the typed array variations. We have map, set, arguments, node lists, which isn't strictly, as Benji told me today, isn't strictly JavaScript. It's a DOM API, but whatever, it's better. And generator objects. So an iterable returns us an iterator, which is simply an object with a next method. Iterator next can be called to request a value, and it will return an Iterator Result object. This is how it looks in TypeScript notation. Again, it's an object which has a next method which returns an iterator result, and it also has an optional return method which also returns an iterator result. The optional return method closes the iterator. When does that happen? We'll see a few examples soon. But basically, when you have iteration which is either interrupted or is terminated using break, continue, return, or throw clauses, it stops the iteration, and you can handle that to do cleanup and things like that. So an iterator result is returned per iteration from the iterator. This is how it looks. An iterator result is an object which has any value, and it has a Boolean done property. And this is how it works. It returns a value and a done false property as long as the iterator has values to return. So we can have finite iterators, ones who have a certain number of members which you can iteate while they haven't been exhausted. And once they have, then each iteration will return simply a done true iterator result object after the last value, and you can call that as many times as you want, and you'll always get done true without a value because there are no more values. That's basically what I just said. And so let's formalize all three. So a protocol is a new thing in JavaScript-ish. And basically it defines interfaces and rules for using them. And if we summarize it, Iterable has an iterator which repeatedly returns iterator results. And in TypeScript notation, I'm not sure this is valid TypeScript, but because it just nested them one inside the other, I think it's pretty close to being valid, but probably not. So an iterable has a symbol iterator property, a function which returns an object which has a next method and an optional return method. Each is an iterator result returning value any type, and a done Boolean property.
So the value should be optional probably, no?
The value, yeah, it can be undefined formally, so. Sorry? The question was that the value should be optional, and my...
In this slide you said it returns only true and stuff, no value.
You can return a value, it's usually just ignored because the point is that it's done. And the value, if you don't have the property value, then it's...
I understand the mechanism, just notation.
Then its value is undefined. So... ES 2015 really loves iterables, and there's a lot of them. There's a lot of constructors, factories, and methods which receive iterables as input. So we have map and weak map, we have set and weak set, we have array from and typed array from. We have array, typed arrays, maps, sets, and objects all have new methods called entries, keys, and values, which all return iterables, so we can iterate them. Promise all and promise race also accept iterables. And as I mentioned earlier, node list, argument, string, map, and set are iterables themselves. So, but that's not where it ends. Iterables are literally all over the place, and they are very convenient to be consumed and to be to use them. So, let's see a few examples of ES 2015 iteration syntax. So while these guys are not syntactical, they're basically functions which accept certain types. This is pure syntax. So we have an iterable, an array is an iterable, and we've seen the for of loop. We also have destructuring assignment. So you can pull the first and the second members out of this iterable, and then this guy will be assigned to here, and this guy will be assigned to the second constant. We can use array spread. Oh, and the third one will never be accessed, because iterators are also lazy, because they can represent also infinite collections of items. Destructuring assignment, array spread. So first again, this will give us this guy. And second and on, this would return us an array with these members. That array will also be iterable.
Why const in the fourth?
Here, why const? Why not?
Why not left?
I'm not modifying it, so it's a const. I use const wherever I do not intend to change it. Let's proceed. So, and the last thing we can postpone to later, and it's a hint to what's coming. Basically, you can also, there's also a yield asterisk, which is a recursive yield. It is also an iterable. So, let's make a simple iterable. And this is our plan. Plan 1. This is our iterable, which has a symbol iterator property, which is a function, which does some initialization, defines our steps, which are not done, not done, not done, not done, have different values. And this is our iterator because it has a next method. What the next method does is it simply returns the current iteration result, okay, and increments our step. And once we've depleted these steps, we'll return done true. And this is the output. So simple, works nice. So an iterable iterator. You don't have to co-locate the iterator, the iterable and the iterator in the same object, but it usually makes sense. So you can you can separate them, but they usually go together, and that is also the case with generators. So this is an example of an iterable iterator which implements both interfaces. So we have plan 2 this time. I've shortened it a bit. And we have, it returns an object which has a symbol iterator property, a function which returns the same object. So this is an iterable. The next method returns us an iterator. No, this is the iterator as well, because it has a next method. And it checks whether we're done, and if we're done, then we return done true. So this works too. Next, we can interrupt, resume, and exhaust iterators. So let's say I have the same plan from the previous slide, the same iterable, and I want to iterate it, and then I break on the very first iteration. This is the output that we get. No. This. My mouse broke. This line is the one that gets printed, okay? But the iteration has been interrupted or paused, and we're kind of in the middle. So we can actually proceed or resume the iteration by just doing the same thing and not breaking this time, and reaching iterator exhaustion. So an iterator which is finite, meaning it has a certain number of members which will end at a certain point in time, when it does end, it's called that it's been exhausted. Also, pausing and resuming iterators means that iteration is lazy. You can't really, well, you can do that with arrays, but not as nicely. Closing.
You explain what the exhausted is. What's the role of finished?
Sorry?
You explain the role of exhausted. What's finished?
What's finished? That's just, yeah. So the question is what's finished here? It's my own term. Like iteration has finished. That's what I meant. It's not a formal term. Okay? Okay, closing iterators using return. So we have the optional return method. And then we can change our previous plan to plan 3, which will close the iterator, a non-exhausted iterator. So I've had to cram some more code in this slide, so I've shortened it even further, but it still does exactly the same and has one more addition. Our optional return method assigns a length which is longer than our which is greater than the amount of steps which we have, so that the done condition, okay, will always be true. And this case, and basically this is where in real code, when we're dealing with, for instance, I don't know, I'm reading or writing a bunch of files and an exception happened, or I don't know, I'm reading from the network and the network stopped responding or whatever. This is where an error gets thrown, or maybe it's a user input, I don't know what. Something abrupt terminates the iteration. So this is where I clean up. This is where I close all of my file handlers, or I don't know, connections or whatever. And then I return done true. So if we try to run again the same thing, our plan 3, and break on the very first iteration, and we try to run it again, we can't, because our iterator is closed. So it basically depends on how you want to implement it. You want them to be resumable, you can do that. You want them to stop.
Is this an error if you try to iterate on it now? Like it's
No, you get nothing.
The question is whether this is an error. And no, it's not an error. It returns done true, always. This is valid, just nothing happens.
So Nick, but calling break invokes the return method if it exists, right?
Calling break from a for of loop calls return. Yeah, that's exactly how it works. And you can also call it manually. If you have an iterator object, you can call its return method. So iterators will be back, and we're at part 2, generators. Generators are really, really cool. They're a very advanced topic. As I was learning the details of it, I wasn't really aware of how cool and advanced this stuff is. So we will cover all of this, but unfortunately, due to time constraints, these guys, these use cases, are reserved to 2 whole different lectures or talks or a workshop. This is some heavy stuff, so we're not going to cover that. I wish I could, and maybe I will, but not now. So, generator function. Generators are functions which can be exited and later re-entered. Their variables are saved across re-entrances. Calling a generator function does not execute it, but returns an iterator for that generator function. So iterators are back. And let's see some syntax. First of all, function asterisk is a function, is a generator function. And we can write them in a bit varying ways depending on their location. And these are all the options there are. So we have a generator function declaration, a generator function expression, which is just the same, only anonymous. We have a generator method inside an object literal, and we can have a class with generator methods. We can have instance generator methods and static class generator methods. All of these do the same. It's just the difference is where they're at. That's all. So a generator returns us an iterator, which returns us iteration results. Let's see some simple code. So we have a function, a generator function, which is called generator, which logs before yield. We'll talk about yield soon enough. We yield yielded value, and we log after yield. And we call the generator function to receive back an iterator. And then we iterate the iterator, and we log the value. So this is the output. Nothing amazing, nothing, pretty much what you would expect. Let's talk about yield. So yield is complex, and we'll get back to it. So the way that it works is like this. Value from next, from the iterator, equals yield value to next. And this is very confusing. And I'll have a few slides just for this part. Yield causes the generator function to pause and returns the yielded value to the calling Iterators Next as the return value, wrapped in an Iterator Result object. You just have to play with generators enough to get the sense of it, to get all the mechanics for it to align. There's no way around it. So we have a very simple function here, which yields foo, and we call it to get an iterator, and then we get all of these guys back. So we see that it has a single value to produce. The value is the yielded value foo, okay? And then we can call next as many times as we want. Iteration is exhausted. We always get done true. A pause generator is resumed by calling the iterators next. Each next call then resumes the generator execution and runs until the nearest yield throw return or end of generator function. So this is how it looks like under the hood. Yeah, Pythons have good generators too, by the way. Okay, so in the last example, we didn't use the low-level interface of iterators. We just used a for of. No, I mean this example. We simply did a for of, right? And this is predictable. But if we go here and we call next manually, which is what the for of loop does, then we can see how everything works under the hood. And this is a bit surprising. So first of all, iterator equals generator invocation. Nothing is printed because nothing gets executed. This whole part hasn't been reached. We only got an iterator object which hasn't done anything yet. Then we call next. And then this piece of code gets executed and our value gets yielded. So it returns back to the iterator as the iterator next invocation value. So this expression here, once evaluated, returns this thing. Then if we call next again, then we resume from this point and execute from this point, and and only this part, this line gets executed, and there's no value to produce, so we get done true. And and if we keep calling it, then we keep getting the same stuff. Basically, we're stuck over here. there's nothing inside the generator function that gets executed. The iterator is exhausted, so it returns done, true.
So there's nothing loopy about a generator inherently.
So there is
Loop inherently.
so you said that there is nothing loopy about generator.
Yeah.
I'm not sure what you mean.
Generator doesn't need
Every
to
time
have
you call next, it doesn't start from the start of the execution.
Okay. Yeah,
But-
correct. Every time you call next, it doesn't run the generator again. No. How you do that is using while true, usually, and we'll have an example for that too. Yeah, but a generator function without which does not have an infinite part to it, a while true, will start execution and will end its execution. That's it.
Or if it has any asynchronous callbacks, calling for the network or anything, it can accumulate, right? I mean, if it runs periodical XHR, for example, you get a result and then you yield it, you start another call, you yield it.
You usually use async generators for that.
Okay.
Yeah, that's more of an async generator's use case.
Every indication of the generator create a separate instance or a separate state, right? It's not
Every invocation of the generator function returns you a new iterator on that generator. Yeah. So, below the surface, yield also returns us a value. So let's see that example again, because it's really confusing. And let's see it in a bit of a different way. So we have the same thing, only this time I inlined the yield clause as a second argument to the second log inside the generator function. And then I do the same. And what we can see in the output is that we have what we expected. We have again what we expected and again what we expected, but we also have this maybe not so expected undefined. Where does that come from? And this is it. The undefined is the value of the yield expression here. Okay, this whole box, once evaluated, its value is undefined. And why is that? Because our for of loop calls next, and calling next without an argument is just like calling any other function without an argument. Its argument is undefined. Okay? So this is where the undefined comes from. Confused yet? Yield and next are also bidirectional. And let's see this here. So we have the exact same function. I warned you guys I'm going to repeat it. This time we have value from next equals yield, okay? And then we print it. And what we see here is yeah, okay, yeah. I confused myself a little bit, but basically what we see here is this time our next methods of the iterator, our next invocations, we also send a value to the generator, okay? And this is the value of the next, which gets returned by this expression and assigned to this constant, okay? So the confusing part isn't that this does make sense. The confusing part is that this is the confusing part. So the communication is bidirectional, but it is also asymmetrical, which means that in the first iteration call, we send this argument, but we don't know where it went. In the second iteration, we send this argument, okay, and we actually receive it by inside the generator, and we print it. Okay, so where did this guy go? This is the confusing part, and this goes back to how yield works. So yield executes the generator from where it is currently paused and up to and including the yield itself. Okay, and this calls for a it broke my head. Basically, so let's follow this with colors and stuff. This is the same function, only without the same code, only without syntax highlighting, because you can't have both syntax highlighting and background colors because it's very, very complex. So let's just follow this. We start from here. Iterator equals generator invocation, right? We get nothing done. None of the function gets executed, okay? This is the only thing that happened, and we now have an iterator. Then we call Iterator Next, okay? And this is the part in green which gets executed up to and after the yield expression, okay? This does not get executed yet. This is what I mean by asymmetrical, okay? This stuff does not happen at a single point in time. There are two different points in time here and two different calls to the iterator. And this is the confusing part. Then, when we call Iterator Next again, our iteration resumes from here and to the end of the generator function. I don't know. I wish I had this slide when I was learning generators, because this could have saved me a lot of headache and a couple of days. So if you need to remember one thing from my entire babbling here, is this, okay? Make it as a background for something, or I don't know, as a cheat sheet. And let's proceed. So an infinite generator, like the one you see here in the background, it's a power generator, and it's infinite. So this relates to the question we had earlier about whether generators are infinite or whether they are repeatable or loop-like by design. Well, they aren't. They aren't at all, except it's cool to make them that way because it makes sense. And while in any other usual, let's say, typical normal code, you wouldn't expect to see a while true loop, in generators, it makes a whole lot of sense. So this is a function which produces a series of functions, which, without overriding its arguments, will produce us natural numbers, which is an infinite series of numbers, which we can iterate infinitely. And so, how can we use this nice thing? Also, it's lazy, which is why it's even possible. So, for instance, we can use destructuring assignment and only call this generator to yield two values, 1 and 2, lazily from the iterator. The rest of the, once we're done with this part, okay, we'll stop at the yield, okay, and that's it. The function is suspended. The iterator is, the function is suspended unless we call it more. So we can call it again, okay, and these two guys, these two examples would actually cause an infinite loop. So one is the array rest operator, and array spread operator, sorry. And the other one is a for of loop without a break, continue, or throw clause. Question?
Destructuring.
the destructuring.
Let's say let's say it was Fibonacci, because natural numbers is boring. If we wanted to know, for instance, the 100th Fibonacci number or the nth Fibonacci number, could we dereference, or could we destructure with an object of key, that number that we want, and it will run through the iterator from 0 all the way to n?
Okay, so the question is, given a generator of Fibonacci, whether we can destructure it to the 100th member, correct?
Arbitrary, but yes.
Using the current destructuring syntax, you can't do that without actually writing 1, 2, 3, 4, like.
You can only destructure this iterable into an array.
You can destructure it, yeah, into an array.
I think that if you put commas and not names, it works.
Oh yeah, you can do that. That's correct. You can put 99 commas in here, and then you'll get the 100th member. Yeah, that'll work. I mean, it won't be really maintainable code or readable, but yeah, it'll work.
I think the question is, can you destructure it into an object with a key of 100?
Yeah, you're right. The question really is whether you can like skip a whole lot of members syntactically, and I think the answer is no. There is no way to do that.
You have a way to destructure?
No, you don't.
Okay.
Aha, I was right.
If you weren't right.
Yes. So, let's see an actual good use case for generators. Something you can use tomorrow. Let's see it in the shape implemented using an iterable and not a generator, and then we'll see the generator version of it. So object entries, this is something that we can use as part of like low-_low-.map function where you can iterate an object. And we want to implement that, and in order to do that, we need to get out of a given object all of its keys and all of its values, right? That's our input data, so we can transform it. So this function receives an object, okay, then gets all the keys of that object, and then returns us an iterator, which on each iteration returns us as the value a tuple, which is basically a two-member array of the key and the value. And when we're done, then we return done. We've seen this before. However, if we break it down, if we analyze what's happening here, we can see that this thing is actually a really awkward and monstrous way of writing a loop. We have an initialization step, we have an iteration step, and we have an exhaustion step or a break condition. Okay? So this kind of represents a loop, which it kind of is, only it's really, really nasty. So we can do better. And this is where generators shine. And this is our generator-based object entries function. It is clear, it's concise, it shows you the meaning of what it is that you're trying to achieve. It doesn't have any boilerplate. For key of keys yield every time per iteration the key and the value. That's it. Even without knowing generators and what yield is and all of that mess which I've talked about earlier, you can pretty much understand what's going on here. Okay, you can assume because there's not a lot of code here. So on the same slide, I've also managed to implement a map function which calls the object entries, okay? And even have an example here. So this is pretty awesome, at least in my opinion. And that's the one that matters on this stage. So generators express the same stuff using just much shorter syntax. And the way that they do that is they reintroduce loop syntax back to iterators. This is their power. Infinite loops or finite loops in generators make a whole lot of sense. So before we end, this is worth mentioning, a recursive yield using yield asterisk. Okay, we have here two functions, and we call them each one, and we get two different sets of values. So the second yield here, the value of the yielded expression is an array, and in this case we get the array back. But in this case, the iteration is actually delegated to the iterable array. So yield asterisk delegates iteration into its argument. Okay? And this is really neat because you can implement recursion using that. You can I don't know, basically you can flatten nested iterators using very concise syntax, simply yield asterisk. And it operates not just on generators, it operates on all iterables because that's the interface. So in this example, we have function generator 1 and function generator 2, and our generator 1 yields 1 start. This is the output. Okay. Then it delegates iteration to the second generator function. So we get 2. Then it in turn delegates to the array the iteration. Then it delegates to the string, which also gets iterated correctly. Watch this. The input is a string, which is an iterable, but the output is its members. Okay? And at the very end, we get this. So this is very, very nice and useful, in my opinion. And unlike in Python, Benji told me they added this syntax for nothing. I disagree. I think this is awesome. And on this stage, I'm right. You can't see the background because I made this slide too late. But here be dragons. So generator use cases. What we've seen so far, they are very awesome lazy data producers because they are iterables. Infinite or finite. They make really cool loops and they rule. But you can also use generators to implement a whole bunch of other things. They can be observers. Using the Iterator's Next method argument, you can push values into the generator. So the generator becomes an observer or a recipient of a stream of data. And because they are bidirectional, it also yields values back. You can make coroutines and make bidirectional communication with generator functions. And but each one of these, like I've mentioned earlier, is a topic for a whole new talk. So we can't do that. This is not really up to date. I've mostly based my talk on these two very awesome chapters of the entirely free online book of the guy called Alex. And I will add to this slide later today or tomorrow, tops, more references and more links so you can guys explore this awesome topic at your own free time. And that's it. Thank you very much.
Pum pa bum pa bum pum pa bum pum pa bum pa bum pum pa bum pa bum pum pa bum pum pum pum.